operate a lab called the Autonomy Owl, where we look at autonomous systems and from the perspective of resilience. And a lot of this is in the context of looking at space systems. And my appointment at Johns Hopkins is joint between being a professor in the systems engineering department and also something called the Applied Physics Lab, which is a major defense contractor to the US government that functions as something called a UARC. And the value of this is that I am able to kind of do some really cool research and then bring it into practice and bring it into the real world through the Applied Physics Lab, which does direct work for the US government. And so obviously the topics I'm going to be discussing today are not secret or anything of that nature, but it's really fun to be able to live on both sides of that playing field because we get to see interesting things that will inform future research. So hopefully I'll be able to share some cool insights with you today. So, just for those of you who aren't super familiar, space communications, here's a really remedial picture of it. We have these three kind of segments that are typical for operations. We have the ground segment, where we have kind of servers and operational support in your command and control center. Then you have a communications signal, which is kind of like your comms infrastructure, your satellite dish, your antennas, things of that nature, and your communication protocol. And you have your space segment, which is like your satellites or your space vehicles, maybe in the future more about space habitation is going to be part of that space segment. And the communication line between these different assets is pretty straightforward today, right? We have our ground segment, so our command and control center, sends a communication to our satellite dish and our antenna, beams it up there, and then it is received by our space vehicle at the right time, given orbits and trajectories and all of those fun things that we have to take into consideration. And it goes both ways, right? We also can send data down, but again, it goes through that intermediary communication signal infrastructure. And it actually raises some really interesting questions, even without considering how space assets may communicate. But when we think about the cyber implications of just how we generally have space communications, when we talk about this ground segment piece here, it's actually not just a one-stop shop for let's send a packet of data to the communication signal and then send it over to space. These ground segments are multifaceted, these ground control systems, and they're often in many locations. And something that is interesting for many people to learn is even for things like the Deep Space Network, if we are having a communication from, let's say, NASA's Jet Propulsion Laboratory at a command center, and we're sending data to asset in orbit, first, we have to send communication to our communications satellite, which would be communicated via an ISP provider, an internet service provider. So it's not necessarily making a direct call to the satellite dish. And so there's a whole bunch of intermediaries in between all of these different segments and a whole bunch of different players who operate at each one, which creates a lot of complexity when it comes to the cyber challenges of this mess. But we get even more complicated very quickly as soon as we add more space segments that are actually supposed to communicate with each other. And so as we are dealing with these space segments that are supposed to communicate with each other, we kind of lose out on any of that access that we had from that link segment. That's because there's no intermediary between the different satellites that are existing out there. And because of that, we can't control as much, and there needs to be quite a bit more of autonomy in that capacity, in that communication capacity. So not only is it more autonomy required, but we actually need to rely more on systems to do their job, to be resilient in case of adversaries or in case of risk. And of course, there's a lot of risk when it comes to space systems, but as we see these space segments start piling up and needing to communicate with each other, this risk gets exploded. So where things stand today when it comes to satellite communications is the US at least has a plan they started a number of years ago called Global Lightning. It was started by the US Air Force. And it kind of said, let's do some space communications. And it was vendor agnostic. They invested in a number of companies to provide space communications between satellites. And there's a whole bunch of different vendors that are out there and have received funding. Starlink is probably the most global and famous one that's out there right now, a SpaceX subsidiary. But there's also ones like Iridium, which has been around for a number of years, as well as OneWeb, and there are a whole bunch of different players who are getting funding to launch constellations of satellites that ultimately need to facilitate communications. Now, oftentimes we think about these communications in the context of being able to provide internet access to people here on Earth. But in order for these satellite constellations to operate properly, they kind of need to communicate with each other. And not only do they need to communicate with each other within their own vendor makeup, but they need to be able to communicate with others, perhaps, that aren't made by the same provider. And we're starting to see a series of a trend towards PLEO, right? Proliferated LEO, where we're having a whole bunch of satellites being sent up, and they're often smaller satellites with less capability, or just smaller satellites that are cheaper, perhaps just as much capabilities as bigger satellites, but cheaper, faster, better. That's kind of the idea of proliferated LEO. And so Project Blackjack was something that was launched by DARPA a number of years ago, again, trying to send a whole bunch of satellites in orbit to see and facilitate the communication infrastructure for space. But we are ending up where we have so many satellites that are going up there that we're starting to run into some problems. And one just came to light over the past couple of days. A OneWeb satellite almost smashed into a SpaceX satellite. It was a Starlink satellite, if I remember correctly. And, right now we don't really have that communication means between OneWeb and the SpaceX infrastructure. So how do we begin to think about this? Well, it's coming soon. We're not totally far off from dealing with these problems. But a lot of it is reliant on optical communications. And so, one of the companies that's on task with doing satellite-to-satellite communications is called General Atomics. And, a VP who's running the project said, getting a laser beam on a spacecraft to point to a laser receiver on another spacecraft accurately enough with the right power levels and the right waveform, this is not easy. And so that's an understatement. It's really, really hard to make sure that you get all of this quite right when it comes to the satellite communications. And working and communicating with lasers can be very effective, but at the same time, it can cause a lot of problems from a cyber standpoint, given there's so many ways of potentially disrupting that laser communication mechanism. So we have been working on this, but there's a long way to go. And there are a number of threats that are out there that will disrupt this side stream communication channel, right, for satellite-to-satellite communications. We have aliens, cyber aliens. We have threat actors who are actively trying to disrupt these communications. We have natural hazards like radiation and bit flipping that we have to deal with on these space systems. And we also have these self-inflicted wounds, which are just bugs in our systems that we're designing, or human error. It's obviously not ideal, but it happens. And so we need to figure out how to manage each of these threats, and each of them have different cybersecurity implications. And each of the cybersecurity implications are derivative of other challenges of satellite-to-satellite communication infrastructure. So, for example, one of the challenges is, as I mentioned earlier, detecting and tracking the receivers, the optical receivers on the different edges of these satellite systems. Really hard to do. There are cyber considerations there. Processing power on the edge. These satellites are, as I said, a lot of IoT devices in orbit, and we don't have really good processing power often for inexpensive satellite communications or satellite systems, especially CubeSats, nanosats, things of that nature. And so you need processing power in order to facilitate communications and be able to provide cybersecurity capabilities on the edge. That's something we don't always have. When we deal with satellite-to-satellite communications, we also have the idea of distortion and how the signal can be distorted because of a whole variety of reasons, especially if you're dealing with anything from the ground to orbit or from orbit back to Earth, and that needs to possibly be bounced off of existing infrastructure to go to another satellite. These are all challenges that we're facing. Storage capacity, again, the same challenge of edge-based storage, same thing as we deal with IoT systems. But perhaps most challenging is the system integration of all of these components. When we have satellites that are trying to communicate with each other, we need to make sure that ones that are made and developed by different vendors or different developers who have different operators can actually work together. And this leads to a whole bunch of a whole bunch of stakeholder management as for one part, but another piece of it is figuring out protocols that can exist in harmony for different types of technology. And this doesn't always work out so well from a cybersecurity standpoint because we don't always have agreement by the original equipment manufacturers. And so, as I was saying, each of these kind of challenges to these side stream comms lead to different, very specific cyber issues. And some of them that are perhaps obvious but are worth calling out are things like jamming and interference. So RF communications is one thing when it comes to signaling of satellites back to Earth or towards other assets. But dealing with lasers and optical communication, there's a whole bunch of challenges that we haven't really figured out how to deal with yet when it comes to the interference. And this is a big ball of wax that we have to address still. There are a whole bunch of single points of failure that we're also dealing with. So if you have a bad actor who's able to usurp one of the central comms mechanisms that facilitate a distributed communication mechanism in space, that would be very problematic. We have very similar security challenges for these optical receivers that we would for any edge device, where you can have false data injection attacks or other basic IoT type vulnerabilities that are present there today. And we even have challenges of like man in the middle, where you are able to perhaps overpower a frequency of communications to be able to intercept or inject data in places that it shouldn't be. And so these security complications are ones that we already have today from a ground segment to space segment, but they're exacerbated by the fact that we don't have as much control when we're talking about satellite to satellite communication mechanisms. But all is not lost necessarily because we're at an early stage, at least from a commercial standpoint of space system satellite to satellite communications. We have the benefit of greenfield development. We can take a lot of the lessons learned from other industries like industrial control systems and port those over to space to space assets. And I'm not saying that we have everything figured out from these other segments or these other systems like industrial systems, but it's a good starting point at least compared to starting with nothing. And so we have some benefits from the commercial standpoint of this fact that we're not dealing with a huge amount of legacy infrastructure yet. We also have new technology that we're coming out with that would be able to help facilitate the monitoring of communications from satellite to satellite to make sure that we actually know what's going on up there. And so the advent or the proliferation of digital twins for space systems is something that we can heavily rely on perhaps for some basic level of assurance when it comes to the security of these assets. And so I think that where I'll end, because I know my time is almost up here, is that we have very different challenges when it comes to satellite issues when we talk about commercial opportunities as we would have with military opportunities. And I think they're very different worlds because while the military sector has been thinking about these problems for a number of years, we're just starting to breach the surface of these issues when it comes to commercial systems. And there's not always a huge amount of information sharing between the two. And so we're going to start seeing major problems pop up in the commercial space sector that maybe the military sectors have seen in the past, but they can't exactly share that information effectively. And so I think that's an increasing challenge that we're going to be dealing with too, to be able to kind of build off of what we learned from the military standpoint to bring to the commercial standpoint. And I think Ali's going to talk to you a little bit about that today. So thanks again for having me. I'm really looking forward to questions because we couldn't get too deep in the 15 minutes that I had. So thanks again.
All right, thank you for that presentation, Professor Falco. And guys, I've been noting down your questions from the chat box. So I think we'll get to those questions during the questionnaire segment. All right. Now, upcoming next, we have Mrs. Alexandra Stickings. Now, Mrs. Alexandra Stickings is a research fellow for the Space Policy and Security in the Military Sciences team at the Royal United Services Institute, RUSI. Her research covers military space programs, space warfare, counter-space capabilities, space situational awareness, arms control, and the intersection of space and missile defense. She has written articles and research papers for a variety of publications. Mrs. Stickings is a frequent speaker at international conferences and regularly provides expert commentary to the media. Mrs. Alexandra holds a Master's in International Security and Global Governance from the Birkbeck College, University of London, a BA in International Studies from the Open University, and a Bachelor's of Sciences in Physics with Astronomy from the University of Nottingham. Now, Mrs. Alexandra will be presenting on the difficulties of defining cyber attacks and space. Mrs. Alexandra, can you take over?
Yeah, hi everyone. Thank you so much for the opportunity to speak today. So what I want to run through is some of the really the challenges when we're confronting cyber attacks against space systems. I'm approaching this primarily from a sort of military perspective, but I will also touch a little bit on the commercial aspects. And you know, the first difficulty we have is when we're talking about a cyber attack in space, what do we actually mean by that? And like so many other things, there are a lot of different definitions, and some of them cover different aspects. I have seen some definitions of cyber attacks that are including jamming, for example, or other types of interference. This is much more really what we call electronic warfare. So I'm going to focus on what I consider to be much more true cyber in this sense. So we're looking at things like corruption of data, interception of data, attacks against the ground systems or those link segments, denial of service, some malware, and perhaps the two most concerning are the spoofing of particularly something like GPS signals, or the ability to take over and control a satellite. I think we've all heard about GPS jamming. This is something we see actually going on quite a lot. But spoofing of GPS is, rather than interference, is actually replacing the signal with a false one. So just imagine a naval ship that thinks it's in international waters, but it's not, because it's getting the wrong signal. These are the kind of things that we're worried about. We think about precision weapons and munitions, GPS guided bombs. If the signal is not real, if it's being replaced by something else, there are some very significant consequences there. We know that so many satellites now have maneuvering capabilities. So we see this in the commercial sector for things, for example, satellite servicing, on-orbit servicing, or even debris removal, but also obviously in the military sense as well. So, you know, the potential worst case scenario of actually gaining control of another satellite. And we know that a lot of states are developing these capabilities, have some of these capabilities, all of the larger space players. They're easier and cheaper often than developing some of the more extreme counter space capabilities like anti-satellite missiles. But I think what's more concerning about, particularly looking at cyber capabilities, is their ability to proliferate to other actors, other state actors, but also potentially non-state actors and proxies. And we see this happening through cyber in other areas. You know, there's a long history of this. So the question is probably not if, but when this will start being felt in the space domain. So why might someone use a cyber attack? And I've mentioned all of these examples. You know, you can just prevent someone from gaining access to space, and that's why space is so important when we're thinking of it, particularly in military terms. It's what are we getting from space? It's secure communications, it's intelligence, surveillance, and reconnaissance data. It's signals for command and control. particularly, in the nuclear area. Weather data, to conduct operations. So any way that an adversary can deny or disrupt that information gives them an advantage. Of course, as I said, there are lots of ways of doing this. We have this whole spectrum of counter-space capabilities, from these kinetic anti-satellite missiles that destroy satellites, through all these other methods like using lasers to dazzle optical sensors and blind satellites, microwave frequencies that can damage the internal workings of a satellite, all the way down to cyber. So I guess some of the question is, what makes cyber perhaps more attractive as a method of denial or disruption than some of these others? And I suppose the main reason is that cyber exists in what we call subthreshold, or the so-called grey zone of conflict. So it's not overt conflict. It's always kind of happening. It's competition, and we see it in every domain. We see it in cyber, in land, in air, and sea, and space. This is always happening. And the other the other thing that cyber gives an advantage is the difficulty of attribution. I think, as Greg mentioned, things that are happening in space, it's very difficult to obviously know what's happening all the time. Your satellite stops working, you can't just go and open it up and try and figure out what happened. So it's happening in space, it's difficult. Was it deliberate, or was it just a failure? Was it just a fault? Was it a coding problem? Some sort of malfunction? Was it something else? Was it radiation? Was it debris? So by being able to use cyber, it's much more difficult for anyone to prove that something happened, that it was you, they can't attribute it, what was your intent? And so there's potential for avoiding retribution. You can get away with it much easier than something that it is a more obvious attack. So how do we respond to this? And I think that the first thing is just accepting that this is going to happen. It's not something that we can prevent totally. And if we look again at the whole range of behaviors of counter space capabilities, there are no real, we're very, very limited in our ability to prevent anything. If you look at the Outer Space Treaty, it's over 50 years old. All it can really do is say you can't put weapons of mass destruction in space. It's just saying you can't put nukes in space. There is nothing preventing any of these other types of capabilities from being used. The ongoing multilateral talks, for example, at the United Nations, the preventing an arms race in outer space discussions, the prevention of the placement of weapons in outer space treaty, they're all stalled. It's very...
I think we lost Alexandra for a moment. So can you please give it time as she tries to rejoin the meeting?
Hello, can anyone hear me?
Yeah, I can hear you. Are you all right?
I'm so sorry. My internet's Zoom just kicked me out completely. So I'm not quite sure what's going on. So I've dialed in on my phone. I'm really sorry. Hopefully it will stay where it is, and I'll carry on. I'm really sorry about that.
Not a problem.
Yeah, I think I was mentioning, so the behaviors, the conversations about behaviors, and I think this is where we might see some progress on counter space capabilities, but again, it's very difficult to get any agreement, and if we do, they'll be voluntary. And I think within the area of the cyber domain, we're also starting to see talks on behaviors, but these are not going to be complete. They're not going to be anything more so than voluntary. So I think we have to accept that cyber threats are going to be something that continues. And again, we have this commercial competition, more satellites in orbit. It's not just the military. Commercial satellites could be threatened. And also we have to think about space then as part of critical national infrastructure and the support it gives to critical national infrastructure. So there is this importance of understanding cyber threats, not just in the military realm, but moving through other aspects of national security and the commercial sector. The really important point, and it's difficult, and I mentioned this because of our lack of understanding and our lack of ability to attribute attacks, is to decide at what point a response is justified, if we can determine it's crossed a line, but where, how do we respond? And this is why it's so difficult to really have conversations sometimes about what we mean by conflict in space, because we still don't really understand, if one actor does something else, how does someone else respond? Is it in space? Is it in another domain? What does a proportional response look like? But I think one of the real difficulties we have when we're talking about cyber attacks is we're often focused on the cause, where it's a cyber attack. Whereas actually sometimes maybe what we should be doing is thinking about what is the effect, regardless of what the method is, it's what is the effect. What type of satellite has been threatened or disrupted? Is it a communication satellite, an ISR satellite? And really, what is that impact? So obviously a satellite, now these obviously are also going to be the most protected, but one that is involved in the nuclear command and control structure. Then you have other military satellites that again are providing intelligence and surveillance, secure communications, and then down the road to something like a weather satellite. So the impact of a cyber attack can be felt differently. Is it a short-term effect, or is it permanent? Are you just denying that satellite and that information for a short period of time? Is it something that's going on longer? And what's the situation on the ground? What is the relationship between those two states at the moment? Is it a time of crisis? Are they in conflict? So there's a lot more to just to cyber attacks than just I hacked your satellite. There's a lot of other considerations that we need to be thinking about. So if we accept that this is the reality, what can we do about it? And obviously the first is resilience, both of your satellites, the satellites themselves, and the whole system. As much as you can to ensure that they are resilient against cyber attacks and can you're not going to necessarily lose your capability. But picking up on what Greg said, the military has been aware of this for longer, but this is not just the military. There's commercialization. A lot of satellites are dual use. They are commercial satellites that may be used for military purposes. Commercial satellites can be a target. Everything can be a target in space. So there is that need for communication. What lessons can be provided to the commercial sector? How do we ensure that new entrants into space are aware of the threats and aware of what they need to do? So I think standards are really important here, industry standards in terms of cybersecurity. But also redundancies, not just in space, but across the domains. So don't think of it just as a communication satellite. It's part of a broader communications architecture that will have segments in other domains. So how does your space segment fit in? You weigh up the relative risks of the different domains, and so you can ensure that if you lose your space segment, you still have as much of a communications capability as you can have. So I guess some final thoughts. Cyber is always a threat. This is not something we can get rid of, but I think definitions are incredibly important. That's something that if we know exactly what it is we're trying to stop, it's easier to stop it. So making sure everyone's on the same page when they're talking about cyber threats in space, and ensuring that there's a community there that is pushing this forward. So that the majority of space actors are acting responsibly and are creating an environment that is able to withstand some of the worst threats. I think I'll finish there and looking forward to any questions.
All right, thank you so much for that presentation, Mrs. Alexandra. All right, now we'll be moving on to the questions and answers segment. So what will be happening is that I'll be moderating the questions. So I'll ask the first question, and then whoever has questions will be allowed to speak, and then so on and so forth going. All right, my question from the chat box, it's a question I got from the chat box, and this one was directed to Professor Falco. The question reads, what are the cybersecurity constraints on Starlink versus OneWeb versus Telesat? Professor Falco?
If I knew, that would be wonderful. But I think one of the challenges that we're also facing, and I know I'm just saying the word challenges all the time in the past hour, but the private sector has been really terrible at disclosing anything when it comes to space systems and cybersecurity. They've kind of totally hidden from public view on what's going on and what steps they're taking. I'm quite frustrated, as are, I think, other people in the community, by the lack of transparency of at least engaging in conversations on this. And there's steps that are being taken in order to actively engage the private sector to understand or help them get their head wrapped around what they can be doing to disclose more or discuss more. There's a excellent group that I'm part of, and I'm confident others on this call may be as well. But it's a working group as part of the Department of Homeland Security in the US on determining if space systems should be a critical infrastructure sector. And as part of this, it's a cross-sector working group. So you have a whole bunch of different industry practitioners who are there alongside people from the government and from the military and academia to try and discuss what can be done better in this area. But we're still a long way off in getting any kind of insight into what's happening behind the veil of, oh, we're a private company, we don't have to disclose these things. So that's kind of my quick assessment there. Sorry, I don't have more insight into the specifics on these technologies.
Can I just come in really quickly on the back of that? I think, in the UK, space is part of critical national infrastructure. So again, what we're having is really differences in countries and how different countries are approaching this. So when we think about the standards that are required, it's not just within countries, it's throughout the international community. The difficulty is when you have companies like SpaceX with Starlink who are moving ahead with all of this, you almost see norms being created by the private sector who are just going ahead and doing this faster than the diplomatic, the arms control, the international community can kind of keep up. And that's what we find is that, by the time, all these countries have sat and discussed and worked out what norms are and worked out what needs to be doing, we have all of these companies who are already doing what they're doing. And I think that's one of the biggest difficulties, particularly with these bigger companies.
All right, thank you for that, Mrs. Alexandra and Professor Falco. Okay, the next question, and it is directed to you both. The question reads, what are your opinions regarding NATO and what further opportunities are there for NATO in the intersection between space and cybersecurity?
Ali, I'll let you take that one first.
Okay, sure. Yeah, so NATO declared space to be an operational domain in December 2019. This was a really big step forward for NATO to actually, recognize space and say, yes, space is incredibly important. We have to do something about it. The difficulty with NATO is that it doesn't own or operate its own space assets. It relies on the assets of member states, disproportionately the US. And then, we have, France, the UK, Germany, Italy, but the majority of NATO states don't actually have their own space programs or involved in as much. So I think, the first step is how do we actually, how is NATO planning on integrating those assets? How do you have interoperability, information sharing? And it does have similar problems with cyber. And I think NATO as an alliance needs to look at the whole structure of space assets within member states, across all the member states, what they're doing, and so how it then sees what the risks are to NATO operations because of the threats to member states. The difficulty, of course, is that the member states also have their own priorities at times, their own ways of approaching this. It's interesting if you look at the US saying space is a warfighting domain. It's a slightly different route that others are taking. It's much more almost belligerent at times. It's much more about conflict rather than space as an enabler of other domains. So I think it's at least starting. It's sort of getting on the right path, but there's still a lot of work to do to ensure across the alliance that there is some space and cyber security. It's not easy, as I said, because it often doesn't own those and operate those assets itself. I don't know if there's anything you want to add, Greg.
I think that was a great summary. Coming from the U.S. side, I think that I don't want to speak for Americans generally, obviously, but speaking for myself, I think that NATO's perspective on space is important, but we continue to see NATO as an organization that doesn't have a lot of teeth, and the problem with that in space is that I don't see NATO launching a whole bunch of satellites up there to actually take action. And there's a lot of guidance coming from them. They don't quite have the tactical experience to make some claims or judgments. I think there's a lot of value in the rigorous thought processes and the geopolitical context that NATO brings to the space security questions. But I think it's a bit challenging and kind of messy when there's a lot of guidance coming from players that aren't actually players. And I think that's one of the reasons why, like, the US was so excited recently when the UK launched their space command, right? Because it's like, okay, UK, you're in the game, let's do it, And I think that's the US perspective, at least my perspective coming from an American standpoint, is like, it's really hard to make guidance and judge on the security concerns of space when you don't actually have assets that are existing in space, or you're not operating things at scale in space. So my take on NATO's perspective on this is a little more sour, perhaps, than a lot of the other European countries. I am currently based in Iceland, so I totally understand and appreciate that European perspective. But with my American hat on, I think that we like to see people play ball with us or against us, or have assets there before they're making big judgments in the space.
Yeah, I mean, I'm hoping what we might see come out of this is the responsibility of all member states to be involved in space security in some way, even if it's not their own assets, but through space domain awareness, through the surveillance of space and those security areas, and to ensure that everyone does have some skin in the game in some way. And I think just to come back on that sort of the non-American perspective, to back to the more European perspective, that some concern, particularly around maybe a US focus more on the Pacific and more on China and less on perhaps the Russian threat in Europe. But what we might see then is more NATO member states becoming involved in the space element because of that perceived threat in Europe. So there's sort of positives and negatives to the US holding most of the assets and what it could mean for the future.
Great point.
All right, thank you guys for that. And the other question, in your own opinion, what would you say constitutes threatening behavior in space? And if it is deemed that a line has been crossed, what responses may they be? In your own opinion, what would you say constitutes threatening behavior in space? And if it is deemed that a line has been crossed, what responses may they be?
I'm happy to start with that.
I think it's definitely a good one for you.
I mean, this is what is really difficult. We don't really know what those lines are, and actually, I think if some states have decided what those lines are, they might not actually be willing to. They don't necessarily want to say this is the line that you've crossed. I think a kinetic attack in space is sort of an obvious behavior. If you have a missile that goes and destroys a satellite, that's a pretty obvious attack. This is what these discussions, I think, on norms of behavior are often about. So if you think about maneuvering satellites that can approach others, if you can have an agreed minimum distance that a satellite can approach another without prior agreement, if you cross that, if you get closer than that distance, then you can say, I am now threatened because there's an agreed limit here, and you've crossed that line, and therefore, I perceive that to be threatening. But when you're getting into these non-kinetic, into the cyber, into all that, it is really difficult. And I said, I think because a similar attack, a similar method of cyber, against a weather satellite versus against a satellite that's involved in nuclear command and control is, it's the same method, but one of them maybe not as threatening as the other. And I think that, those are incredibly difficult lines to come up with. And this is why I don't think we've really seen them. Response, again, there are so many considerations. What was the length of the attack? Is it permanent? Is it not permanent? What was the impact felt on the ground? Was there a severe loss of secure communications during an actual operation that resulted in casualties, for example? Is going to, your response is going to be much different to something that happened in peacetime and there's no operation going on. So these are all the conversations I think that are happening. Is what is that threat? But how do we respond? It's probably not going to be in space. It could be a kinetic strike in the air domain or on land. It could be diplomatic. It could be economic. It could be sanctions. There's all these different ways that people could respond. The problem is, because it hasn't happened yet, we don't really have anything to go on to base that. It's all quite theoretical. I'm sorry, I can't give a more sort of obvious answer, but this is why we are having these discussions all the time.
All right, thank you, Mrs. Alexandra. Now a question from the chat box. The question reads, what if satellites orbiting at different levels are going to block each other's signals by launching thousands of satellites? Is this a threat? If satellites orbiting at different levels are blocking each other's signals by launching thousands of satellites, is this a threat? It's a question from the chat box.
A quick response to that is perhaps. It depends on how smart these satellites are, if they have propulsion. It depends on a lot of the space domain awareness questions that we haven't all figured out yet. I know, and this is public information, like the US and EU partners are very actively soliciting and requesting advancements in space domain awareness because of the challenge and the mess of all the satellites being up there and not just blocking communications but hitting each other or being increased space debris. This is all part of the problem we have, and so I think that yes, there's absolutely the likelihood that a whole bunch of satellites being up there, especially those that are deemed P-LEO, proliferated LEO satellite constellations, that's going to cause a major problem. But we don't have our head wrapped around what's out there right now, or where it's going, or where it's heading, or just kind of almost randomly flying around, and we don't have much good insight to this, and it's not ideal right now. So there'll be problems, I guarantee it. Ali, what's your thoughts?
Yeah, I mean, very similar to you. I think, yeah, theoretically, of course, you could put up a few thousand satellites to do that, but the consequences of that are too unknown. That in terms of, you've got to manage the satellites, you've got all those potential problems of space traffic management, debris, and I think sometimes when these ideas are kind of being thought of, you forget how complicated the environment is up there. And I've heard people say, oh, what if you could create debris on purpose in order to affect someone's satellite? It's like, you can do that, but you have no idea what's going to happen after that. You have no idea how that satellite is going to break up and what implications that could have for that orbit and for others. So yeah, it's theoretically possible, but I think is is much more difficult to do in practice, and the implications are actually kind of quite terrifying. So I would very strongly advise against anyone doing that.
All right, it's almost time up, so I'll be bouncing 3 more questions to you both. The first question, the other question, it reads from the chat box. It reads, what standards have been established for cybersecurity of space systems? What standards have been established for cybersecurity of space systems?
Formally, my quick thought is none, but there's a lot of informal guidance on what should be done. I think at least in the US, the closest is SPD5, but those aren't really standards. They're just like very general recommendations for adopting generic risk management practices. So I think there's a lot to be done still. I know that NIST, the National Institute of Standards and Technology in the US, is working on this. I'm sure some people who are participating in this call today are engaged in some of these discussions with the Space ISAC that is in the US. But at least from the US standpoint, we don't really have any standards right now on these topics. And at best, they're adopting standards from the critical infrastructure learnings that we have.
All right, thank you. One other question. What are the cybersecurity risks of on-orbit servicing? What are the cybersecurity risks of on-orbit servicing?
I mean, I guess, yeah, I mean, I guess the biggest risk is the potential for a satellite to be, for loss of control of a satellite. So you're not necessarily servicing something, you're looking at damaging, perhaps, and using a satellite to damage. For me, that's probably the most worrisome. I guess it's more looking at the technology that's being developed for on-orbit servicing and how that can be repurposed, for potentially malicious purposes, and what role cyber might play in that in terms of, corruption of data or interference in that way. That's probably what I would see as the main threats.
I would just add to that the whole system integration bit that I mentioned very briefly in the talk. This is a perfect opportunity for vendors to not get along and requiring some kind of meeting of the minds from a communication standpoint, communication protocol standpoint, and how you actually are able to create that interlinkage when we are doing servicing, and the proximity of sensors, proximal sensors for satellites. A lot of these satellites are promiscuous, so they're not necessarily directing communications to any specific area. It's like anyone who's around can hear what's going on sometimes. And that's really problematic when you're talking about getting very, very close to an asset. And maybe that asset is operated or managed or controlled or owned by an adversary or someone who just wants to steal data or anything like that. So there are concerns with it. They're not being thought of top of mind right now, at least from the commercial standpoint. They're trying to just figure out how to do it first, but it's coming.
All right, thank you. And one very last question before we conclude the series. What are the how are cybersecurity issues addressed on mega constellations? It was a question from the chat box, and it reads, how are cybersecurity issues addressed on mega constellations?
I think there's two perspectives here. There's probably the military standpoint, and then there's commercial standpoint. I can speak at least to the commercial standpoint. It's not addressed right now. I think we're just really not seeing a lot of communication about what they're doing, if anything. in terms of how they're going to be managing the risk across all of the different assets that are there. It'd be ignorant to assume they're doing nothing, but I think it's very possible they're not doing a whole lot. So I think that's kind of from a commercial standpoint. Ali, maybe you can speak to the military standpoint.
Yeah, I mean, obviously, you know, we don't know everything that the military is doing. You know, you would assume that you know, military plans for constellations like that do have a significant cybersecurity aspect to it. You know, I would be shocked if they weren't. But I think, you know, from a military perspective, there is a concern, and I agree with Greg that, you know, probably in the commercial sector we're not seeing enough, or, you know, again, there's a lack of communication. And I think you know, there's just the concern around, in general, the commercial sector, because, as I said, you know, what happens in space can affect everyone. You know, it's not just your satellite stops working. That satellite, if it's just there, you can't control it, could have impact on so many other satellites and systems. So I think the concern from a military standpoint is from the commercial sector, and it's being responsible to the environment and to every actor in the environment. That's what everyone needs to be doing. So improving that communication, I think, is key.
All right, thank you. And I think this will conclude our webinar. And we would like to thank you, Professor Falco, and you, Mrs. Alexandra Stickings, for doing this with us. It's been a tremendous experience, since from the planning, all those emails, postponing, all those stuff. We would like to thank you guys for being so wonderful and being patient with us during this planning. And we will also like to thank our leaders, Antonia and Thea, for being so patient and guiding Nilofa and I so well in the webinar. And also we'd like to thank the participants, and you guys have been really active on the chat box, so we thank you for that. Please feel free to connect with us on Slack, and feel free to reach out to Professor Falco and Mrs. Alexandra should you have any other more questions that you feel were not addressed in this series. And guys, yeah, thank you so much, and thank you. Yeah, that's it. Thank you.
Thanks for having us. Thank you.
Yeah, thank you for having us. It was a pleasure.
All right. Thank you, guys.